Quadratic functions self-assessment. First question or problem. Define, explain vertex. Please pause the video to work these out. Write out your own statements. Then compare to mine. Define, explain vertex. Vertex is the highest or lowest point on the parabola. It's where you'll find the maximum or minimum value. Let's sketch a graph and see what that looks like. Get a visual representation. You might have a parabola opening up. In which case the vertex will be located here as a minimum. And if you have a parabola opening down, the vertex will be located here as a maximum value. All right, second question. Define or explain the axis of symmetry. The axis of symmetry is a line that splits the vertex evenly in half. If you fold the parabola onto itself, it will fold at the axis of symmetry. It is a vertical line intersecting the vertex. Let's get a visual of the axis of symmetry. Alrighty. For this parabola, we will have the vertex located here approximately. This is just a sketch. And the axis of symmetry, typically identified with a dotted line. You don't actually graph it. You don't want to go bold. This is where the parabola will be split in half. The axis of symmetry goes to the vertex. It's identified with x equals. And in this case, we could say it's equals 3 for our sketch. The third exploration, write the basic quadratic function. The basic or parent function for quadratics is ... Here we go. F of x equals x to the second power. Okay. Number 4, write a quadratic function in standard form. Standard form. I can write a quadratic function in standard form. f of x. I'll go with 2x squared minus 3x minus 7. And in standard form, we have a, b, and c values. They might equal 0. In this case, a equals 2. B equals negative 3. And c equals negative 7. Next, number 5, write a quadratic function in vertex form. I can write a quadratic function in vertex form. I can write a quadratic function in vertex form. Yes. Okay, a quadratic function in vertex form. Go with our dependable f of x equals, how about 1/2 x minus 3 second power plus 4, and h value equals 3 because we have x minus h, and the k value located at the back is 4. Our vertex h k is the vertex, and that point is 3, 4. With vertex form, you can readily identify the vertex. Number 6, write a quadratic function in intercept form. I can write a function in intercept form. Here we go. F of x equals negative 4 x plus 1 x minus 2. That makes the y-intercepts, and correction, that makes the x-intercepts are negative 1, because negative 1 plus 1 equals 0, negative 1, 0, and 2, because 2 minus 2 equals 0. And how did I get those? X plus 1 equals 0 from this factor, and x minus 2 equals 0 from this factor. You'll also see the intercepts as written as x equals negative 1 and 2. If you don't see them written as the ordered pair for the points. That's 1 through 6. Uh-oh. Numbering problem. This will actually be 7, 8, 9, 10, and 11. All right. What can you identify from a quadratic function in standard form? Let's go back to standard form. Where are you? We can identify the a, b, and c. We can identify the y-intercept. equals -7, so it's the C value. The ordered pair will be 0, -7. With the A value being positive, we know the parabola opens up. And we could calculate the axis of symmetry. X equals the opposite of B over 2A. Again, that will be the axis of symmetry. We could calculate that. Where are we? Next, what can you identify from a quadratic function in vertex form? There we go, vertex form. We can identify the vertex. This is the A value. A equals 1/2. So the parabola opens up with a positive A value. And that's it. We know the vertex and the parabola opens up from vertex form. Next, what can you identify? Oops. The standard form, we did vertex form. I should ask, what can I identify from a quadratic function in intercept form? Intercept form. Intercept form is also known as factored, not refactored, but factored form. Factor the quadratic function and you get intercept form. So I can readily identify the x-intercepts from intercept form. And I have the A value, so this parabola opens down with A less than 0. A is a negative value. All right. Do everything you can with these. I have quadratic function here in standard form. X squared minus 4x minus 5. Let's set up a graph. And we need a solid line. Y-axis and our x-axis. I think I can pull that y-axis over. Are you thinking about this? We have a y-intercept of -5 from the C value. 1, 2, 3, 4, 5. Okay, I know the quadratic function will open up because I have a +1. I can anticipate that. I can determine my axis of symmetry using -b over 2a. B is -4, so that's going to be the opposite of -4. A is 1 divided by 2 times 1, 2. So at x equals 2, I have the axis of symmetry. Now we can substitute 2 into the function, evaluate the function at 2. We get 2 squared minus 4 times 2 minus 5. That equals 4 minus 8 minus 5. That equals -11. So the vertex is located at 2, negative 11. Five, 6, 7, 8, 9, 10, 11. All right, this is a point on the graph. I have a point mirroring that on the other side of the axis of symmetry. Since A is 1, from the vertex I can go over 1, up 1. I have enough points to sketch my parabola. And that gives us an idea of what it's looking like. Great. And let's close it out. There's a couple of things on 9 and 10, which are really 11 and or 10 and 11. So recognize this one as a quadratic function in intercept form or vertex form, x minus 5 gives us an x-intercept at 5, 0. And x plus 1 gives us an intercept at negative 1, 0. Let's make that a negative 1, like I said. A value is negative. This parabola opens down. Since these are intercepts, let me give you an interesting fact. The vertex will be halfway between these intercepts. We don't want to block that out. So the vertex will be located at a value halfway between 5 and negative 1. That will be at 2 something. The axis of symmetry is x equals 2. And we can plug in a 2 or evaluate at 2. 2 minus 5 is negative 3. 2 plus 1 is 3. So the opposite of negative 3 times 3 will be 9. The vertex is at 2, 9. Looking at the last function, what can I do? I can recognize this as vertex form. The vertex will be 2 comma negative 9. Parabola opens up. The axis of symmetry goes through the vertex. It will be located at x equals 2. All right, how'd you do with your self-assessment of quadratic functions? Please let me know. Thank you very much for watching.